Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening. Yeah, continuing with quadrilaterals. This is the first question in exercise 8.1. We have completed all the examples before this exercise. Okay. So the statement is if the diagonals of a parallelogram are equal. Okay, before this, we'll recall the definitions, okay, of these four terms. What is a parallelogram? How do we define a parallelogram? Okay, a parallelogram is a quadrilateral. Listen to me. A parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. A quadrilateral is a parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. What is a rhombus? A rhombus is a parallelogram in which all sides are equal. A rhombus is a parallelogram in which all the sides are equal. What is a rectangle? A rectangle is a parallelogram in which one angle is a right angle. What is a square? A square is a parallelogram. Both this will come here, in which all the sides are equal and one angle is a right angle. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Okay. Parallel sides, parallel sides. Again, we'll see. What is a rhombus? A rhombus is a parallelogram in which all the sides are equal. What is a rectangle? A rectangle is a parallelogram in which one angle is a right angle. What is a square? A square is a parallelogram in which all the sides are equal and one angle is a right angle. Both these put together, in which all sides are equal and one angle is a right angle. So these are the definitions of parallelogram, rhombus, rectangle, and square. I've shared all this with you. Apart from the definition of every quadrilateral, I have also shared the properties. I've shared them on WhatsApp. I've shared all the properties of a parallelogram, rhombus, rectangle, square. All properties I've shared. You need to learn of them. All right. No yawning, because if you're yawning, I'll start yawning. Yawn is contagious, right? Yawn is contagious. Yeah, then even I'll be, oh, yeah, it's so nice to go to bed now. So please, you can help yourself, go to the washroom, wash your face, and come back, sit brisk, right? Sleepy eyes, drowsy eyes. Right. So here, if the diagonals of a parallelogram are equal, then show that it is a rectangle. We haven't done this. Yeah. Now, the first thing we need to remember is you should not draw the figure like this because you're given a parallelogram, but you have to prove it's a rectangle. You're given a parallelogram, but you'll have to prove it's a rectangle. So supposing you draw the figure like this, then finally what will you say? Therefore, ABCD is a rectangle. No, but ABCD does not look like a rectangle. We are given a parallelogram. So you're going to draw the figure like this. But finally, how are you going to end the proof? Therefore, ABCD is a rectangle. But does the figure look like a rectangle? No. So always draw the figure to suit the final result. Show that it's a rectangle. So you're going to draw the parallelogram like this. You're going to draw the parallelogram like this because a rectangle is a parallelogram. Rectangle is a parallelogram. You can draw a parallelogram like this, but you cannot draw a rectangle like this. You cannot draw a rectangle. This is a parallelogram. You cannot draw a rectangle like this. This is the rectangle. It is also a parallelogram. Okay. So show that it's a rectangle. So the figure is going to look like a rectangle. Let's call it ABCD or PQRS. ABCD is a parallelogram. So what are you given? Given parallelogram ABCD. Correct? And the diagonals are equal. That means AC is equal to BD is given. AC is, don't write anything now. AC is equal to BD is given. If the diagonals of a parallelogram are equal, so ABCD is the parallelogram, diagonal AC is equal to diagonal BD, then show that it's a rectangle. To prove that ABCD is a rectangle. All right, now proof. Now, how do you show that a parallelogram is a rectangle? Definition. Everything is in the definition. What is a rectangle? A parallelogram in which one angle is a right angle. But this is already a parallelogram. So one part is done for us already because the given figure is a parallelogram. Okay. To prove that the quadrilateral is a rectangle, you need to prove it's a parallelogram in which one angle is a right angle. But the given figure is already a parallelogram. So this part is done for us already because the given figure is a parallelogram. So you just have to prove that one angle is a right angle. So in this figure, you need to show that angle A is 90 degrees, or angle B is 90 degrees, or angle C is 90 degrees, or angle D is 90 degrees. You need to prove one of these four angles is 90 degrees. Then by the definition, ABCD is a parallelogram in which one angle is a right angle. Therefore, it is a rectangle. Right? See, now if you're, I think I mentioned this in the last class, if you're asked this question, is 20 a composite number? Is 20 a composite number? So to answer this question, you're going to use the definition. What is the definition of a composite number? A number that has more than two factors. Any number that has more than two factors is called a composite number. A number that has exactly two factors is a prime number. Okay, a number that has more than two factors is a composite number. So if you have to decide if 20 is a composite number or not, definition. It should have more than two factors. So 1, 2, 4, it has more than many more factors. It has a few more factors, but yeah, now this is a composite number. We're using the definition, right? So in the same way here, to prove it's a rectangle, we have to use the definition of a rectangle. How do you show it's a rectangle? It should be a parallelogram. It's already a parallelogram. Okay, then one angle should be a right angle. No, that's not there. So that's what we have to prove. And to prove that, we are going to take up these two triangles. We're going to take up these two triangles. This triangle ADB and the other triangle, what's that? ABC. Correct? Understand which two triangles? Now this triangle has the diagonal BD and this triangle has the diagonal AC. So take these two triangles. Now we know that the diagonals are equal. It's given to us that the diagonals are equal. So BD is equal to AC given. See, okay, what are we going to do? We're going to show that these two triangles are congruent to each other. We're going to show that these two triangles are congruent to each other. So BD is equal to AC. And then AD is equal to BC. Why? Because in a parallelogram, opposite sides are equal. AD and BC are the opposite. See, in these two triangles, they are different sides. In the two triangles, they are not opposite sides equal. These triangles are from this figure. Look at the main figure. In the main figure, AD and BC are opposite sides of the parallelogram and they're equal. Because it's a parallelogram, opposite sides are equal. So AD is equal to BC. Then AB is the common side. Both the triangles stand on the same side AB. AB is the common side. So in these two triangles, AB is the common side. Then AD is equal to BC and BD is equal to AC. So by SSS congruence criterion, the two triangles are congruent. So now let's list in the two triangles ABD and ABC. All right. So let me start with AB. AB is equal to AB. Then, okay, let me write it in the way I've named now. Once again, any order is fine. But So we'll say common side, opposite sides equal, and given. Okay. So AB is equal to AB, common side. AD is equal to BC, opposite sides of parallel. BD is equal to AC, given. So how do you name in the correct order? How do you name it in the correct order? See, I can tell you one more method. See, if you start from any vertex and you just go around the figure. Okay, you just go around the figure. Now, supposing I start from B, I go around the figure like say like this. I should like kind of meet all the vertices from one. I start from one vertex. I need to go around the figure and meet all the vertices. Okay, so I say I start from B. I meet the vertex A. I meet the vertex D, and I stop there. I just want to meet the vertices. So in which order are you going? See here, there is this one and this one marked. You're going along that. You start from here and then BAD. So if you say BAD is congruent to, use the same path here. How did you go? You went along this side and this side like this. So you'll have to go like this right here. Can you make out this one and this one? No, not clear? No, see, here the single line and here this double line. So I start from here, I go past the single line and then the double line. So do the same thing here. I have to start from here. I have to go past the single line and then the double line. So then it will be A, B, C. Anyways, you can go. Let's do something else, okay? Let's do something else. Now, supposing I start from the vertex D. The thing is, I need to meet all the vertices, okay? So supposing I start from vertex D. So I start from vertex D, I can come anyways, okay? So supposing I come down like this, I say hi to B, and I say hi to A, and I stop there. So I say hi to D first, D, then I say hi to A, B, and then to A. You should do the same order here. Well, you should treat everybody equally, right? So do the same thing here. You came past this side which has 3 lines, then this side which has 1 line, no? There's 1 line. So I started here. I came past this side which has 3 lines, and then this side which has 1 line marked like this. So do the same thing here. Where are 3 lines here? So I should start from here. Come past the side that has 3 lines. And then 1 line here. So it will be CAB. If I say DBA, then it will be CAB. CAB. See, both are correct. DBA. See, DBA means CAB. Remember it. 1, 2, 3. 1, 2, 3. So here it is DBA, no? Here it is DBA. That is D is 3, B is 1 and then 2. This is D is 3, B is 1 and 2. So here also it should be 3, 1, 2. Yeah, C is 3, A is 1 and B is 2. You can name them in different ways. Okay. But for this order, this only is the correct order. For this order, this is the correct order. You cannot write this one and this one. That's wrong. Or see, actually, you can just try this by yourself. It's not difficult. But if at all you're not comfortable with this, then you can always go with. I said take up any 2 sides, no? I said take up any two equalities, which is a common vertex. Here A, here B. Correct? Here A, here B. Take up any 2 equalities. So write AB as BA. BAAD. Correct? Remember, the common vertex here is A. So BAAD. Here it's B. So AB, BC. So it is BAD and ABC. BAD and ABC. Any one of the methods you can use. I told you this earlier when we were at congruent triangles. Okay. So now I think you should take the effort to, learn how to name the triangles in the correct order. So now these 2 triangles are congruent by the SSS, congruence criterion. SSS. So CPCT, we have here I want to say that this angle is equal to this angle. I want to say that these two angles are equal. So A of the first triangle is equal to B of the second triangle. See here, A of the first triangle is equal to B of the second triangle. 2, 2. See here, A of the, I want to say that this angle is equal to this angle. And you can see here, yeah, they are equal because A of the first triangle is equal to B of the second triangle. Yeah, 2, 2. Both are in the second position. So they are corresponding angles. Not parallel lines, transversal corresponding angles, not that corresponding angles. They are related, like this is the second, A is in the second position, the first triangle, and B is in the second position, the second triangle. That way corresponding. So angle A is equal to angle B. Angle A is equal to angle B, CPCT. But angle A and angle B are adjacent angles of the parallelogram. So they are supplementary. In a parallelogram, adjacent angles are supplementary. In a parallelogram, adjacent angles are supplementary. Okay, that is in a parallelogram, this angle plus this angle is equal to 180. Okay, so this is the angle A, this is angle B. They're equal. Angle A is equal to B, but A plus B is 180 because adjacent angles are supplementary. A plus B is 180. So A plus A is 180 because B is A. A plus A is 180. So twice of angle A is equal to 180. A is equal to 90 degrees. A is equal to 90. So we've proved that one angle is a right angle. So it's a rectangle. All right? Right on. You may not have, I don't know if you've completed the notes so far. It's okay, just write the correct exercise number and the question number and work out this. Yeah, online children, please take down this proof. Exercise 8.1. Question number 1. Done writing? No? Okay. Finish? Yeah. Louder, louder. Correct. See, because you SAS, is it? Tell me what information will you write for SAS? Yeah, so that angle equality. Tell me that angle equality. Which angle here is equal to an angle here? Yeah, you wanted to say something. No, you can use SAS if you can mention an angle equality. Sorry? AD equals BC. No, no. One angle of the first triangle should be equal to one angle of the second triangle. Angle ADC. Reason? Reason? Okay, you want to say angle 1 is equal to angle 2, right? What's the reason? Either it should be given or you should be able to give a reason as to why they're equal. So you feel it's a rectangle, so the corner is, you have to prove it's a rectangle. It's only a parallelogram now. And in a parallelogram, opposite angles are equal. Adjacent angles are not equal. They're only supplementary. Okay? None children? No. Okay, okay. Online children completed working?
Yes, ma'am. Just a minute, ma'am.
Okay.
Yes, ma'am. Completed, ma'am.
Yeah.
Completed, miss.
Yeah. Good. Done? Yeah. Done? Okay. We'll just do it again. The End result is you should show it's a rectangle. So we draw the figure to look like a rectangle. We call it ABCD. And what do we say? Given, quick, don't read from your book. Given what? Parallelogram ABCD. Given parallelogram ABCD. Diagonal AC is equal to diagonal BD because it's given diagonals are equal. So AC is equal to BD. To prove that ABCD is a rectangle. ABCD is a rectangle. So we need to take up this triangle and this triangle, which are called DAB and CAB. So in these two triangles, AB is equal to AB, common side. DA is equal to BC or CB because in a parallelogram, opposite sides are equal. DB is equal to AC, given. Diagonals are equal, given. So by the SSS rule, the two triangles are congruent. Should name the triangles in the correct order. Okay. CBCT, this angle 1 is equal to this angle 2. But this angle 1 and angle 2, they are adjacent angles of the parallelogram and they're supplementary. So angle 1 plus angle 2 is 180 because adjacent angles of a parallelogram are supplementary. But 1 and 2 are equal. So 1 plus 1 is equal to 180. Twice of angle 1 is equal to 180. Angle 1 is equal to 90. So now what do we have? We have a parallelogram ABCD in which one angle is a right angle. Therefore, ABCD is a rectangle. No, you're yawning non-stop. Please go wash your face. Show that the diagonals of a square are equal and bisect each other at right angles. Show that the diagonals of a square. So we are given a square. Given a square ABCD. Show that the diagonals of a square are equal. So given square ABCD, to prove that diagonals are equal. So AC is equal to BD. To prove that AC is equal to BD, you must prove that they bisect each other. You must prove that the diagonals are equal and they bisect each other. That is, AC and BD bisect one another. AC and BD bisect each other. And also, you must prove that they bisect at right angles. They bisect each other at right angles. Okay, then I'll put that in one. At right angles. Okay. Okay. Now, when you're given a square, you can use all the properties of a square except what you have to prove. Now, you know in a square, every corner is a right angle. In a square, all the angles are 90 degrees. You can use that. You can use all the properties of a square except what you have to prove here. See, you have to prove that the diagonal AC is equal to diagonal BD, right? That is a property of a square. In a square, the diagonals are equal. When you see the properties of a square, you will find that the diagonals of a square are equal. But that has to be proved here. So you cannot use that. But supposing you're showing the two triangles are congruent, you cannot write that. In a square, diagonals are equal. So you cannot use that equality there because that's what you have to prove. So remember that in this case, you're given a square, you can use all the, while proving, you can use all the properties of a square except what you have to prove. Okay, all right. Now, you don't have to actually prove that AC and BD bisect each other. You can just say ABCD is a square. That means it's a parallelogram. ABCD is a square. That means it's a parallelogram. And in a parallelogram, the diagonals bisect each other. So you can just mention that ABCD is a square. That means ABCD is a parallelogram. In a parallelogram, the diagonals bisect each other. So here also in ABCD, square ABCD, the diagonals will bisect each other. In a parallelogram, diagonals bisect each other. ABCD is a square, which means it's a parallelogram. So because it's a parallelogram, the diagonals will bisect each other. You don't have to prove that. You can just mention that because it's a parallelogram, the diagonals bisect each other. But at right angles, you have to prove. At right angles, you will have to prove. All right. So coming from AC is equal to BD. Prove that AC is equal to BD. So you'll have to take up you'll have to take up two triangles which have those sides. The first triangle has which side? A, B, D. It has BD. And this triangle A, B, C. Correct? DAB, CBA. Why do we take up these two triangles? Because this triangle has BD and this triangle has AC, and we have to show that they're equal. So when you have to show two angles or two sides are equal, the triangles you consider must have them. Otherwise, what's the point? If you take two triangles and they don't have the lines, they don't have the side, they don't have BD or AC as sides, then what's the point taking them? What are we trying to prove? If we have to show that AC equals BD, you will have to take a triangle that has AC, another triangle that has BD. So when you prove that these two triangles are congruent, CPCT, you can get that result. Okay. So we can use all the properties of a square except what you have to prove. So in a square, all the sides are equal. In a square, all sides are equal, no? So AD is equal to BC. AB is a common side. And in a square, every angle, every corner is a right angle. Right angle. So what's, you wanted to use the SAS rule, right? So here, so by SAS congruence criterion, the two triangles are congruent to each other. Correct? Online children?
Yes, ma'am.
AB is the common, yeah, AB is the common side. Then opposite sides are equal. AD is equal to BC. And it's a square. So every angle is a right angle. So angle A is equal to angle B is equal to 90 degrees. So by the SAS congruence criterion, the two triangles are congruent. Okay, so if you have to name it, if you say DAB, because this side is equal to this side, right? So if you call it DAB like this, DAB, then you must say CBA like this, CBA. Because these two lines and then one line, like the CBA. Here also these two lines and then this one line. The path in which you're traveling. It might be funny, but that way you can just look at the figure and write the names. No, it's not funny. So this is the order. Okay, they're congruent. So CPCT, you can see this. DB is equal to CA. Yeah, DB is equal to CA. DB is nothing but BD. They're not different. See, sometimes you may have this question in your mind. BD and DB both are the same. Here the order is not important. BD, DB, the order is not important. That is a line segment. The line segment can be called AB or the line segment can be called AB or BA. Both is the same line segment. But when you name the triangles, like in the triangle, DAB is different from DBA. Here you cannot say you said AB and BA both are the same. So instead of writing DAB, I wrote DBA. You said AB, BA are the same. ABBA as a line segment is the same. But when you name a triangle, there every vertex position is important. There you cannot write DAB as DBA because AB is equal to BA. No. Okay, so see here, DB is equal to CA. So DB is equal to CA. That's what we have to prove. DB is here. This is DB, this is CA. So we prove that the diagonals are equal. So it's so simple. We just, everything is Either information equalities are either given or they are a part of the properties of that figure. You just have to list it in such a way that they fit into a congruence criterion. That's all. Okay, now next we'll have to show that AC and the diagonals bisect each other. It's a parallelogram, so they bisect each other. At right angles, that means where the diagonals meet. What do we mean by that? Where the diagonals meet, no, these two diagonals. Where do they meet? They meet here, right? So there it should be 90 degrees. So you can prove that this is 90 or this is 90 or this is 90 or this is 90. Any one of those four angles, because here if one angle is 90, then all the other angles will be 90 degrees because vertically opposite angles, and you know it. When two lines intersect at right angles, when two lines meet at right angles, every angle around that point will be 90 only. So you have to prove that at this point, see, diagonals bisect each other at right angles. So these are the two diagonals. They meet at right angles. They meet at right angles. So you need to prove that this angle is 90 degrees. Any one of the four angles, I have marked that. For this, what you have to do, you'll have to take up any two. See, you have four triangles, right? We can see four triangles. Take any two adjacent triangles. Take any two next triangles, adjacent triangles. You should not take this triangle and this triangle. No, that will not work. You must take up, you can take up any two adjacent triangles. So like this one and this one, or you can take this one and this one, or this one with this one. Take up any two adjacent triangles. So we are going to take up okay. So we're going to take up a triangle DOC and triangle BOC, correct? DOC, BOC, they are adjacent triangles. Okay, now in these two triangles, this side is equal to this side because it's a square, all sides are equal. This is the common side. And then this side of the first triangle is equal to this side of the second triangle because O is the midpoint of BD. The diagonals, they bisect each other. That means O is the midpoint of BD. O is also the midpoint of AC. That's the meaning of diagonals bisect each other. O is the midpoint of AC. O is also the midpoint of BD. O is the midpoint of AC. O is the midpoint of BD. So O is the midpoint, which means OD is equal to OB. OD is equal to OD. Today you're very tired, huh? So in these two triangles, CO is equal to CO common side, then CD is equal to CB, because in a square all the sides are equal, and DO is equal to BO, because O is the midpoint. O is the midpoint of BD. SSS rule, the two triangles are congruent. Name the triangles in the correct order, and the order can be, one of the orders can be, if you say COD, if you say COD, then you must say COB. COB. COD, COB. Okay, so you can see O of this triangle is equal to O of this triangle, which is O in the first triangle, this one, which is O in the second triangle, this one. So angle 1 is equal to angle 2, CPC2. But they form a linear pair, no? 1 plus 2 is 180, linear pair. 1 plus 2 is equal to 180, linear pair. But 1 and 2 are equal, so 1 plus 1 is equal to 180. 2 can be replaced with 1. Twice of angle 1 is equal to 180. Angle 1 is equal to 90 degrees. So we proved that angle 1 is 90. That means the diagonals, they bisect each other at right angles. Bisect, we already mentioned why. So bisect each other at right angles. Right? Yeah?
Why did we prove that triangles not rectangle?
Gayatri, once again.
Why did we actually prove that triangles are congruent?
Why should we prove that they are congruent? Huh?
Yeah, ma'am.
Okay. So you're saying directly we can do 1 plus 2 is 180, is it?
Yes, ma'am.
Then how will you replace 2 with 1?
Because it's bisecting, so that angle will be this angle.
No, 1 plus 2 is 180. But how do you know that they're equal?
Because it's O is a midpoint and Q is equal to OB.
In a square?
Yes, ma'am.
No, in a square, the diagonals, they meet at right angles. But that's what we have to prove. So as of now, angle 1 plus 2 is 180 because they form a linear pair. But 1 and 2 are not equal angles, right? You'll have to show that they're equal angles. No, you have some doubt there, but 1 is equal to 2 is not known. 1 plus 2 is 180. That is because BD is a straight line. BD is a straight line, so the sum of the angles on a straight line is equal to 180. So angle 1 plus 2 is 180.
Yes, ma'am.
Now to get this angle 1 plus 1 is 180, twice angle 1 is 180, you need to prove that 2 is equal to 1, no?
Yeah.
Yeah, to show that 2 is equal to 1, we'll have to take up these two triangles, show that they are congruent and they are equal because they are the corresponding angles in the two triangles. Okay. Okay. So that's about this one, children. Write down. Please write down. Anand, children, please take down this proof. Completed online, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Next one. Diagonal AC of a parallelogram ABCD bisects angle A. See, there are two things, bisecting an angle, bisecting a side. Bisecting a side meaning the side is cut into two equal halves. Bisecting an angle again means the angle is divided into two equal portions. Now, supposing the measure of this angle is say 80 degrees, no, okay, 60 degrees. So if it's bisected, see, this one is cutting through the angle, right? This is the angle. This is the angle A. And you can see that the diagonal AC is cutting through the angle. This diagonal AC. So the 60 degrees becomes 30 degrees here and 30 degrees here. Angle is bisected, divided into two equal angles. If a side is bisected, like supposing like, this line segment bisects AB, that means this one is the midpoint of AB. The side is bisected. That means this half, this portion is equal to this portion. Okay, so here the angle is bisected. So diagonal AC of a parallelogram ABCD bisects angle A. So this angle is divided into two equal angles. Show that it bisects angle C also. You must show that this diagonal AC, no, as it goes like this, it also divides angle C into two equal portions. Now it's given angle A is bisected. You must prove that angle C is also bisected. Very simple. See here. One, two, three, four. Okay. Now, parallel line, transversal, parallel line. Why are we saying parallel line? Because it's a parallelogram. Opposite sides are parallel. Opposite sides are parallel. So alternate interior angles are equal. Angle, angle. நான் போட்ட செட்டில் எந்த angles இருக்கு? Angle 3 is equal to angle 2. Alternate interior angles are equal. Angle 3 is equal to angle 2. Now, consider this Z. Parallel line, transversal, parallel line. Angle 1 is equal to angle 4. Alternate interior angles are equal. So there is one Z like this. Here we have angle 1 and angle 4. There is another Z like this, where we have angle 3 and angle 2. Angle 3 is equal to angle 2. Alternate interior angles are equal. Angle 1 is equal to angle 4. Same reason. But it's given that 1 is equal to 2, right? Angle 1 is equal to angle 2 is given, right? So angle 1 is equal to angle 2. This is given. These are because they're alternate interior angles. Now compare this. Angle 1 is equal to angle 2. Let's just take a measure, okay? So supposing 60 degrees, just for example. Okay, 66. Okay, I'll not take any measure. Let me just use a letter. Angle 1 is equal to 2. So let me say A. Okay. Now here also we have 2. That means this is A, no? So 2 is equal to 3 means this is also A. Now there is 1 here. That means this is A. And 1 is equal to 4. That means this is A. All the angles are equal there. That means angle 3 is equal. See, that means angle 3 is equal to angle 4. Angle 3 is equal to angle 4. If angle 3 is equal to angle 4, that means AC bisects angle C. AC bisects angle C. Angle 1, angle 2, angle 3, angle 4. So we say angle 1 is equal to angle 4, alternate interior angles are equal. Angle 2 is equal to angle 3, alternate interior angles are equal. But angle 1 is equal to angle 2 given. So when you compare all this, 1 is equal to 2, but 1 is equal to 4 and 2 is equal to 3. When you compare all this, angle 3 is equal to angle 4. Because see here, there is 1 here, no? And there is 2 here. 1 is equal to 4 and 2 is equal to 3. But 1 and 2 are equal. So 3 and 4 should be equal. 1 is equal, angle 1 is equal to angle 2. But 1 is equal to 4. And 2 is equal to 3. That means 3 and 4 are equal. To understand this, you can use that letter like I showed you, no? All the angles are equal. So that means angle 3 is equal to angle 4, which means AC bisects angle C. Is that fine? So we finished the first part. It bisects C also. So for that, no congruency. You can just do it like this. No congruency. Just like this you can do. Now you need to show that ABCD is a rhombus. Definition. Okay. How do you prove it's a rhombus? It should be a parallelogram. All sides equal. It's already a parallelogram. So you just have to prove that all the sides are equal. There also we have, some kind of concession. The concession is it's already a parallelogram. So we already have opposite sides equal. We already have opposite sides equal. So remember, when opposite sides are equal, but you'll have to prove that all the sides are equal. It is enough. See, okay, 1, 2, 1 is equal to 2, 3 is equal to 4, right? Opposite sides are equal. Now you want to prove that all the sides are equal. For this, it is enough if you prove, it's enough if you prove angle 1 is equal, sorry, side 1 is equal to side 4, or 4 is equal to 2, or 2 is equal to 3, or 3 is equal to 1. Prove any two adjacent sides are equal. Prove any two adjacent sides are equal. I'll show you why. When already opposite sides are equal, but you need to show that all the sides are equal. But you need to show that all the sides are equal. It is enough to prove adjacent sides are equal. All right? I don't know what I said because of the noise coming from there. Opposite sides are equal. We have to prove all the sides are equal. For this, it is enough to prove one pair of adjacent sides are equal. Any one pair of adjacent sides are equal. We'll see why and how that works. 1 is equal to 2. 3 is equal to 4. Now we'll prove that this, see, this is side, okay, side 1 is equal to side 2, side 3 is equal to side 4, opposite sides equal. Now say we prove that side 2 is equal to side 3, supposing. Now we'll just take the side 2 as some 6 centimeters. So 3 is also 6 centimeters. Then there's 3 here, no, so 6 centimeters. But 3 is equal to 4, so this is 6 centimeters. There's 2 here, 2 here, so this is 6 centimeters. That means 1 is also 6 centimeters. So can you see 1, 2, 3, 4, all 6 centimeters? All sides are equal. All the sides are equal now. So when opposite sides are equal, but we need to prove all sides are equal, it is enough if we prove any one pair of adjacent sides are equal. Any one pair of adjacent sides are equal. See, it will work even if you prove any one pair. So we'll just take a different pair now. We already know side 1 is equal to side 2, side 3 is equal to side 4. Okay, supposing we prove that side 1 is equal to side 4. Okay, one pair of adjacent sides. 1 is equal to 4. So say 1 is 7 centimeters. Then 4 is also 7 centimeters. There's 4 here, 7 centimeters. Okay, there is, so 4, 7 means 3 is also 7 centimeters. 1 is 7 centimeters. 1 is 7 centimeters. So 2 is also 7 centimeters. So you can see 1, 2, 3, 4, all 7 centimeters. Yeah. So how do you prove that one pair of, adjacent sides are equal? That also, you don't have to do congruency. We can do it like this. Angle A is equal to angle C. Yes or no? Why? What's the reason? Opposite angles of a parallelogram are equal. Allegedly. So angle A is equal to angle C because in a parallelogram, opposite angles are equal. Now, is angle A bisected? Yes. Is angle C bisected? Yes. Then only you can use half. Half of angle A is equal to half of angle C. எப்பயுமே நம்ம இந்த half எல்லாம் யூஸ் பண்ணக்கூடாது. Only when two things are equal, their halves are also equal. That you can use only if, in this case, when the angles are bisected. So angle A is equal to angle C because opposite angles of a parallelogram are equal. Half of angle A is equal to half of angle C. Now we'll number it. 1, 2, 3, 4. Now, what is half of angle A? Half of angle A is angle 1 or angle 2. Anything you can write. It's angle 1 or angle 2. And what is half of angle C? Angle 3 or angle 4. Write anything. Now, for half of angle A, if I write 2, supposing I write angle 2, then what should I write for half of angle C? No, I should write 4. Okay. So now in triangle ABC, in triangle ABC, in triangle ABC, angle 2 is equal to angle 4. Angle 2 is equal to angle 4. So we know the isosceles triangle property, right? In a triangle, when two angles are equal, the sides opposite to them are also equal. So we have proved that AB is equal to BC. Adjacent sides are equal. So already opposite sides equal. Now we proved adjacent sides are equal. One pair of adjacent sides are equal. So it's a rhombus because it's a parallelogram in which all the sides are equal. That's all. Let's do this again. You must say angle A is equal to angle C. Angle A is equal to angle C because opposite angles of a parallelogram are equal. Half of angle A is equal to half of angle C. You can even write half of angle A as 1 and half of angle C as angle 3. Then it will be the other triangle. In this triangle, in triangle ADC, angle 1 is equal to angle 3. So that means AD is equal to CD. Because in a triangle, when two angles are equal, the sides opposite to them are also equal. So AD and DC are a pair of adjacent sides. They're equal. So that means all the sides are equal. So parallelogram in which all sides are equal is a rhombus. Right on?
Completed, ma'am.
Yeah. Children are still writing here. All of you finished, online students?
Done, ma'am. Yes, ma'am.
Okay. But Sunday and Harsha? Sanjay?
Yes, miss.
No, completed writing down this proof?
Yes, miss.
Okay. Got it. Done? Done, children? To the sun, go down and come back. I've given them the instruction that class can, they shouldn't be doing this work during the class time. ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. But we'll have to show that it's a square. So I'm going to draw a figure that looks like a square. Online children, there is some drilling work going on here at the center. Are you able to hear me clearly?
Yes, ma'am.
Are you able
Yes,
to hear the noise that's coming from here?
no, ma'am.
Okay, good. Okay. ABCD is a rectangle, but I draw it like a square because we have to prove that it's a square. ABCD is a rectangle in which diagonal AC bisects angle A. Oh, so angle 1 is equal to angle 2, as well as angle C. So angle 3 is equal to angle 4. Are you listening, Rahul? Okay, ABCD is a rectangle or square, and diagonal AC bisects angle A and angle C. So angle 1 is equal to angle 2, angle 3 is equal to angle 4. Okay, show that ABCD is a square. So again, the same situation. It's a rectangle. Already opposite sides are equal. What is a square? Rectangle, square. What's a rectangle? It's a parallelogram. Square is a parallelogram in which one angle is a right angle. In which one angle is a right angle and all sides are equal. So we already have these two. We already have these two because it's a rectangle. We only have to show that all the sides are equal. We only have to show that all the sides are equal. But already opposite sides are equal. So how do you show all sides are equal when opposite sides are equal? You just have to prove that one pair of adjacent sides are equal. We're just using the definition. What we have is a rectangle. We need to prove it's a square. A rectangle is a parallelogram in which one angle is a right angle. A square is a parallelogram in which one angle is a right angle and all sides are equal. So this is that one other thing which you have to prove. These two we already have, right? All sides are equal, we'll have to prove. But again, opposite sides are already equal. So it is enough to prove one pair of adjacent sides are equal. One pair of adjacent sides are equal. So, which was say, supposing you want to prove that these two sides are equal. Okay. So same procedure like we did for the last one. Angle A is equal to angle C. Why? It's a rectangle. Every angle is 90 degrees. Okay, but opposite angles are equal, no? Also, it's a parallelogram. The rectangle is a parallelogram, so opposite angles are equal. Now they are bisected also. So half of angle A is equal to half of angle C. So what's half of angle A? Angle 2. Half of angle C, angle 4. Angle 2 is equal to angle 4. So in this triangle, angle 2 is equal to angle 4. That means this side is equal to this side. Opposite sides equal, adjacent side. One pair of adjacent sides equal, so all sides equal. So it's a square. ABCD is a square. We should next prove that diagonal BD bisects angle B as well as angle D. Okay, we'll have to prove that this diagonal bisects angle B as well as angle D. So if I number this 5, 6, 7, and 8, what should I prove? I should prove that angle 5 is equal to angle 6 and angle 7 is equal to angle 8. Okay. To prove angle 5 is equal to angle 6, angle 7 is equal to angle 8. So that means I have to prove triangle D. Okay. D of this triangle should go with what of this triangle? Okay, 1 minute. Let me put it like this. 1 second. I'll just number this also. I'll just number this as 9 and 10. If I name this triangle as DAB, that is 7, 9, and 5, I want to prove that 7 is equal to 8, right? So what is 8? D. And I want to prove that 9, 10, leave it. But in place of 9, I should have C. And then I should prove that 5 is equal to 6, right? So in place of when it's B here, I should have B here also. See, it's like this. Let me write it like this. 7 should be equal to 8. Okay, let me put 3 dashes. Okay, 1 minute. I'm trying to use some technique also. 1, 2, 3 vertices congruent to 1, 2, 3 vertices. Okay. Now for 7, I want 8 here. What happened? Yes. For 7, I want 8 here. For 5, I want 6. Then the third vertex, 9, 10. How do you name the triangle? D, B, A. Congruent to E, C, B. Correct? Please. Oh, sorry. Sorry. 7 is okay. 8 is D. 6 is B, and C. All right. So this is what you'll have to prove. Assuming that now you have understood like congruency very well, and you can from this order itself you can write everything. DB is equal to DB. Take up these two triangles. DB is equal to DB. Common side. DB is equal to DB. Common side. BA is equal to BC. Why is BA? BA is equal to BC. It's a square. All sides are equal. Then DA is equal to DC. DA is equal to DC. Because here it's a square. All sides are equal. See, we are talking about the sides of the two triangles. So we'll have to prove that DA or DBA is congruent to DBC, correct? Okay. So from this itself, we can write DB is equal to DB common side. Okay. BA is equal to BC. BA is equal to BC. All sides are equal. Then DA is equal to DC. DA is equal to DC. Again, all sides are equal. So these two triangles are congruent by the SSS. You understand what I write? Do we understand that? You can just name the triangles in the correct order and write the three things using that itself. So they are congruent by SSS rule. So CPCT, what do you get? Angle D is equal to angle D. That is angle 7 is equal to angle 8. Then angle B is see here, angle B is equal to angle B. B here is equal to B here. Angle 5 is equal to angle 6. A is equal to C, we don't need that result. So what is 7 is equal to 8? That means BD bisects angle D. And what is 5 is equal to 6? BD bisects angle B. Finish. Yeah, please write down, children. I'll just come back. Please write on this. Done writing? Online children?
Done, ma'am.
All right. We finished this one the other day. You can just take down the proof now. We already discussed this the other day, children, in the last class. Please write down the proof, read what is given, understand and write down. Done? Completed, yes. Rahul, finish writing? Online children, completed?
Yes, miss. Yes, ma'am.
Okay. Okay. So how do we show that triangle without using your book? You should answer. How do you show the triangle APD is congruent to? Yes, Hari Darshan, start. Close your books. Online children also, please don't use your book. Yeah, tell me. Tell me one equality, Hari Darshan. BC is equal to AD. Reason? Yeah. Opposite sides of parallelogram are equal. Very good, both of you. Okay, next. Anything else can you say, Hari Darshan? BC is equal to AD. Perfect. AP is equal to A. What is equal to BQ? Not AP. What is, see here? AQ is equal to PC. Yeah? No, but are they the sides of the triangles which we have considered? We have considered two triangles, right? What you say, the equality you say should be relevant to these two triangles. நீங்க சொல்ற AQPC இந்த ரெண்டு triangles இல்லையே sides are. Yeah. QC is equal to reason. Reason. Online children. BC is equal to AD then. What's the next one? DP is equal to PQ given. DP is equal to PQ given. Then angle. Correct. This angle is equal to this angle. Angle D is equal to angle B. Why? No, no, stop. Why? What's the reason? No, no, no. Repeat. Which are the two angles equal? He mentioned. Angle. Use three letters and name the angle. Angle. No. PDA. Correct. Is equal to angle. PQC. QBC. Reason I wanted from you, Sachin. What's the reason? Why are these two angles equal? Opposite? They are angles, so you can't say sides there. Which school you go to? Which school you go to? Okay, in short, what do you say? Huh? No, not that, but like, don't you say Z school? So what's the first letter? What angles are there? Alternate interior angles, parallel line, transversal, parallel line. Harsha, I don't know if you're trying to say something, but it's not audible. Kindly disable your mic. This angle is equal to this angle. Alternate interior angle is equal. So what's the rule? SAS. SAS rule, the two triangles are congruent. So CPCT, you have AP is equal to CQ. AP is equal to CQ, CPCT. And how do we show that ABQ is congruent to AQB is congruent to CPD? Yeah, Devitra, tell me. AB is equal to? Okay. Yeah, Rahul. DQ is equal to DP, correct? Reason. AQ is equal to PC. Okay, reason. Yeah, name using 3 letters. Angle ABQ is equal to angle CDP, correct. These two angles are equal. Why? Why? Alternate interior angles are equal. Parallel line, transversal, parallel line. See, this angle is equal to this angle. Alternate interior angles are equal. Right? So what's the rule? SAS. The two triangles are congruent. So CPCT, you have AQ is equal to CP. Okay, somebody online tell me, how do you show that it's a parallelogram? APCQ? Yeah, Harsha or Sanjay. Sanjay, tell me, why is it a parallelogram? APCQ?
Don't know, miss.
Don't know. What a bold answer. Don't know. Okay, let's know that now. Yeah, tell me. Okay, Divitra. Divitra, yes, one second. Yeah, Divitra. AP? No, not clear. AP and CQ, they're equal. Because we proved it here. AP is equal to CQ. Yeah, we proved it. Then yeah, we proved that AQ is equal to, we also proved that AQ is equal to CP. So what do you observe in the quadrilateral ABCQ? Opposite sides are equal. So in a quadrilateral, when opposite sides are equal, it's a parallelogram. You'll have to remember the properties of the parallelogram. In a quadrilateral, when opposite sides are equal, it's a parallelogram. In a quadrilateral, if opposite angles are equal, opposite sides equal parallelogram, opposite angles equal parallelogram, opposite sides parallel parallelogram. One pair of, I think that's deleted, but if one pair of opposite sides are parallel and equal, parallelogram, all that is listed in the, yeah, notes I've shared with you, properties. Just take down this answer. It's time, children. So we'll discuss this in the next class. We've already discussed this earlier. Then we have one more to complete this exercise. Yeah, take down this. Quickly complete this. We have discussed this in session 1. We'll do it again in the next class. Now just take down the answer. Question and the answer. Sorry? Oh, that's your choice. If you want to write the question number exercise 8.1, question number 6, and take down from the proof, you can do that. You can write from given. I leave that to you. Okay. So this is exercise 8.1, question number 6. Write the correct reference number.
Just finished this.
Okay. Sanjay, please share the pictures of your classwork, today's classwork.
Okay.
Yeah. Completed? All right, so that's it for today's session. Thank you. Good night.